Okay, question 16 is the numbers P, Q, R, and S satisfy the following equations. So P plus 2Q plus 3R plus 4S is equal to K, and 4P is equal to 3Q is equal to 2R is equal to S. What is the smallest value of K for which P, Q, R, and S are all positive integers? So the second equation, 4P is equal to 3Q is equal to 2R is equal to S, tells us that S must be equal to a multiple of 4, since P, Q, R, and S are positive integers, and that it also must be equal to a multiple of 3, and also a multiple of 2. So if we want the smallest possible value for K, we want S to be as small as possible. And so what we have to do is we have to try and find the smallest possible value of S, which is a multiple of 4, a multiple of 3, and a multiple of 2. Clearly, the smallest possible value of S is 12. So S is equal to 12. And if S is equal to 12, then that means R must be equal to 6, Q must be equal to 4, and P must be equal to 3. And so that means the smallest value of K is 3 plus 8 plus 18 plus 48, which if you add all these up comes to 77. And so the answer is D. Okay, so question 17 is Bethany has £11 coins and some 20p coins and some 50p coins in her purse. The mean value of the coins is 52 pence, which could not be the number of coins in the purse. So the first thing we're going to do is set up an equation using the mean. So if we let the number of 20p coins equal x, and the number of 50p coins in her purse equals y, so x equals num 20p, and y is equal to num 50p, then we can set up the equation 1100, because the £11 coins will add up to 1,100 pence, plus 20x plus 50y divided by the number of coins she has, so 11 plus x plus y is equal to 52. So if we times both sides of the equation by 11 plus x plus y, we get 1,100 plus 20x plus 50y is equal to 52 times 11 plus x plus y. And if we then simplify this even more, we get that 528 is equal to 32x plus 2x. And so x plus 16x is equal to 264. Okay, so we know that y plus 16x is equal to 264. So now what I'm going to do is going to rub some of this out just to make more space. Okay, so we have the equation y plus 16x is equal to 264. We know that 16 times 16 is equal to 256. And so 16 times 17 is 272, which is greater than 264. So what this tells us is that x is greater than or equal to 0, but less than or equal to 16. And let's also just note that the number of coins in her purse, so num coins, is 11 plus x plus y. So x is greater than 0 and less than 16. So if we let x is equal to 16, so let's say x was equal to 16, then that means y must be equal to 8. And so the number of coins, so I'm just going to call that n. So this is n. So n must be equal to 11 plus 8 plus 16, which is equal to 35. So we know that 35 is possible. And so if we decrease the value of x by 1, then clearly the value of y must increase by a greater amount. And so what we can then do is we can just start decreasing x by 1 and seeing what the value of y must be. So what we can now do is we can test x is equal to 15, and this should give us a larger number of coins needed, because if we decrease x by 1, then y must increase by a greater amount to compensate for the 16 that has been lost. Now let's check x is equal to 15. So if x is equal to 15, then that means y is equal to 24, and so n is equal to 50. So as you can see, 50 and 35 are both possible. And since if we decrease the value of x any further, the number of coins in her purse must start to increase. So if x was 14, the number of coins in her purse would be higher than 50, and so the number of coins in her purse can never be 40. Okay, question 18 is, P, Q and R are the three angles of a triangle when each has been rounded to the nearest degree. Which of the following is a complete list of possible values of P plus Q plus R? Okay, so if we let P dash plus Q dash plus R dash equal to 180 degrees, where P dash plus Q dash plus R dash are the original angles of the triangle, what we can now do is we can create some inequalities. So if you have an angle and you round it to the nearest degree, then that means that angle must at most increase by 0.5 or at most decrease by 0.5. So if we have the angle P, this must be greater than or equal to P dash minus 0.5, but also it must be less than P dash plus 0.5. And we can do the same for Q and R. So Q must be greater than or equal to Q dash minus 0.5 and Q dash plus 0.5. Okay, if we then add these inequalities, we get that P plus Q plus R must be greater than P dash plus Q dash plus R dash minus 1.5 and less than or equal to P dash plus Q dash plus R dash plus 1.5. And since P dash plus Q dash plus R dash is 180, P plus Q plus R must be greater than or equal to 180 minus 1.5, which is 178.5, and less than or equal to 180 plus 1.5, which is equal to 181.5. And since P plus Q plus R is an integer value, because the P and Q and R have all been rounded to the nearest integer, the possible values of P plus Q plus R are in fact 179, 180, and 181, and this corresponds to A. Okay, question 19 is, how many pairs of numbers m and n are there such that the following statement is true? A regular m-sided polygon has an exterior angle of size n, and a regular n-sided polygon has an exterior angle of size m. So, because we're dealing with regular polygons, we know that 360 divided by the number of edges of a shape is equal to the exterior angle of the shape. And so, for the first statement, a regular m-sided polygon has an exterior angle of size m, we can generate the equation 360 divided by m is equal to n, and so 360 is equal to mm. For the second statement, we can say that 360 divided by n is equal to m, and so again 360 is equal to mn. Okay, so basically what we want to do is we want to try and find the number of different factors of 360, and these will be our different values of m and n. So 360 is equal to 2 cubed times 3 squared times 5. And so the number of factors of 360 is 3 plus 1 times 2 plus 1 times 1 plus 1. And all I've done is I've added 1 to each power. So 3 plus 1, 2 plus 1, and 1 plus 1, and times them together. And this will give me so 4 times 3 times 2, that's just 24. So 360 has 24 different factors. So you may think that the answer is 24. However, you have to be careful, because if we have values of m and n, by doing this method here, we have included pairs where m is equal to 1 and 2, and pairs where n is equal to 1 and 2. However, we have to be careful of these, because we are dealing with m-sided regular polygons and n-sided regular polygons, and clearly a polygon cannot have 1 or 2 sides, and so this means we have to take away 4 of the pairs, and so the number of pairs is 24 minus 4, which corresponds to 20, which is C. Okay, so question 20 is, the diagram shows a semicircle of radius 1 inside an isosceles triangle. The diameter of the semicircle lies along the base of the triangle, and the angle of the triangle opposite the base is equal to 2 theta. Each of the 2 equal sides of the triangle is tangent to the semicircle. What is the area of the triangle? Okay, so to work up the area of the triangle, what we're going to do is we are going to try and work out the length of the height of the triangle and the length of the base of the triangle. And as you can see, I have labeled the triangle PQR, and I have joined the top vertex to the center of the semicircle, and have also joined the point at which the triangle touches the semicircle to the center of the semicircle. So what we want to do is we want to try and find lengths PU and lengths QR. So first, let's find length PU. Well, because PQR is an isosceles triangle, and all I have done is drawn the line of symmetry of the triangle, the angle UPT is equal to theta. So this is theta. And since the point T here is the point at which a radii of a circle meets the tangent to the circle, this angle here is 90 degrees. So now let's consider triangle PTU. So triangle PTU. So using sine, we could say that sine theta is equal to the opposite over the hypotenuse. And since the opposite to the angle theta is the length TU, and TU is just the radius of the semicircle, we have sine theta is equal to 1 divided by the hypotenuse, which is PU. And so this means that PU is equal to 1 over sine theta. What we can also do is we can fill in some other angles. So we know that this angle, so we know that the angle PUT is equal to 90 minus theta, because the angles in a triangle add up to 180 degrees. And so this means that the angle TUQ is equal to 90 minus 90 minus theta, which is equal to theta. So we know that this angle here is also theta. And because angles on a straight line add up to 180 degrees, this angle here is also a right angle. So if we now consider the triangle TUQ, so triangle TUQ, using the using cos, we can say that cos theta is equal to TU divided by UQ, which is the adjacent over the hypotenuse. As we have discussed, TU is 1 and the hypotenuse is UQ, so divided by UQ. And so UQ is equal to 1 over cos theta. But also notice that UQ is half of QR, which is the base of the triangle. So QR is equal to 2 over cos theta. And this means that the area of the triangle is 2 over cos theta times 1 over sine theta times a half, which is just half times base times height. And so this 2 cancels with this 2. And so we get that the area of the triangle is equal to 1 over sine theta cos theta. And this corresponds to E.